Dear students, now we have come to the question number 11 of the model paper. The question says, a box contains one red cube, three green cubes and one blue cube which are identical to each other. Two cubes are taken from the box at random without replacement. Draw a tree diagram to show the possible outcomes and their probabilities. Using the tree diagram, find the probability that in part 1 both cubes are green, part 2 neither cube is green, part 3 one cube is blue. Now here we have to show the possible outcomes in a tree diagram. Before that, we must identify or understand how many steps should be there in this tree diagram. That is according to the experiment. The experiment is taken two cubes at random without replacement. So taking two cubes we can interpret as taking one cube first and without doing any replacement take another cube. So first choice and second choice are there. So there must be two stages in the tree diagram. This is the first stage. At the first stage, the outcome may be a red one or a green one or a blue one. The probability of getting a red cube is 1/5 because there are altogether 5 cubes, one is red, and probability of getting green cube is 3/5 because there are 3 green cubes, and for the probability of getting blue cube is also must be 1/5. That is the first stage of the experiment. So the expected results for the first stage of the experiments may be like this. Now when you extend this tree diagram to the second stage, we have to think that if the first cube was R or red, what will be the second cube? Now when you have taken a red cube first, the remaining cubes in the box are 3 green cubes and 1 blue. They are altogether 4. So there must be only 2 possibilities for the second choice. They are green and blue. The probability of getting a green cube is 3/4 because there are 4 cubes, 3 are green and 1 is blue. The probability is 1/4. And then again we think, if the first cube was green, what will happen? If first one was green, then again the number of cubes in the box will be only 4. Out of those 4, 1 is red, 2 are green and 1 is blue. Therefore there are 3 possible outcomes for the second stage. Those are R, G and B. The probability of getting R is 1/4. Probability of getting G or a green cube is 2/4 and B is 1/4. Now again we have to think about, if the first cube was blue, what will happen to the second one? If the first one is blue, then the remaining cubes in the box are 3 red cubes and 1 red cube and 3 green cubes. Therefore there are only 2 possible outcomes. Those are R and G. probability of R is 1/4, probability of G is 3/4. So this is how we have to, so the hidden argument is there when you draw this tree diagram. So you have to do that argument, and then you have to decide the probabilities of each branch of the tree diagram. And here using this diagram we can identify there are so many compound events. Those are R and B. Maybe R and B. First one may be R and second one may be G. That is the result we can read as RG, and this the other one as RB, GR, GG, GB, then BR and BG. Those results we can list out like this with their probabilities. RG, the probability of getting RG, first one red and second one green, is the product of the simple events 1/5 and 3/4, that is 3/20. Likewise, we can list out the probabilities of each compound event like this. Now we can easily get the correct answer for the questions asked in parts asked in the question. First part is probability that both cubes are green. Both cubes are green means we can write it as the event as GG. So this one we can represent in the symbolic form as PGG. That is equal to 6/20. Then the second one, probability that neither cube is green. So we have to select from the tree diagram the events in which the green is not exists. That means PRB and PBR. Or in the all the other events, the G is included. So we have to select event in which the green is excluded. So the probability of this one, probability of RB is 1/20. Probability of BR is again 1/20. So the total probability is 2/20. Then third part is probability that one cube is blue. One cube is blue. So we have to select the events in which B is indicated. So B is there in 4 events. Those are RB, GB, BR and BG. So we have to add the probabilities of all 4 events to get the probability of the compound event that we are asked. So that is 1/20th plus 3/20th plus 1/20th plus 3/20th, that is 8/20. So this is the answer for the part 3. So this is how we have to get the answers to the parts of the question using the tree diagram. So very carefully we have to draw the tree diagram. You have to think about the main stages of the experiments, and according to the experiment stages we have to draw the possible outcomes and the probabilities. After that we can write all events, list out them and write the probabilities, and using them we can answer the parts given in the problem. So in the next video we hope to meet you with the question number 12.